seamlessly integrating real-time push notifications in Expo with AWS DynamoDB and Lambda. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to Expo and AWS integration. Expo is a robust framework for building React Native applications, providing a rich ecosystem of tools and services that simplify mobile app development. One of the most crucial aspects of modern mobile applications is the ability to send real-time push notifications, keeping users engaged and informed. AWS offers a robust suite of services that can be seamlessly integrated with Expo to manage push notifications effectively. In this podcast, we'll explore how to incorporate real-time push notifications in an Expo project using AWS DynamoDB and Lambda. Setting up Expo for push notifications. Before diving into AWS services, you must set up your Expo project to handle push notifications. Expo provides built-in support for push notifications, making it easier to manage tokens and handle notification events. Install Expo Notifications package. Start by installing the necessary package. Expo install Expo notifications. Configure push notifications. Update your app.json or app.config.js with the correct permissions and notification configurations. Expo, Android. Permissions, notifications, iOS. Supports tablet, true. Bundle identifier, com.yourcompany.yourapp. Config. Google Services file, /Google Service info.plist. Request push notification permissions. In your React Native components, request permission to send notifications and retrieve the push token. Import as notifications from Expo notifications. Import as permissions from Expo permissions. Async function register for push notifications async. Const status equals await permissions.get async permissions.notifications. If status equals granted. Const status equals await permissions.ask async permissions.notifications. If status equals granted. Alert failed to get push token for push notification. Return. Const token equals await notifications.get expo push token async data. Console.log token. Return token. Assigning push notification tokens. Once you have the push notification token, storing it securely and associating it with the user in your DynamoDB table is essential. Adding a push token field to DynamoDB tables. Create a DynamoDB table. If you haven't already, create a DynamoDB table where user data will be stored. Add a push token field. Modify your table schema to include a push token field. This will store the unique token assigned to each user. Generating and assigning push tokens to users. After retrieving the push token in your Expo app, save it to the DynamoDB table alongside the user's data. Import API from AWS Amplify. Async function save push token user ID push token. Const data equals body user ID push token semicolon await API. Post your API name /users data. Creating a Lambda function for sending notifications. AWS Lambda allows you to run back-end code in response to events. In this case, the event is a new push notification being sent to a user. Setting up a Lambda function with AWS Amplify. Amplify setup. Ensure AWS Amplify is initialized in your project. Amplify init. Amplify add function. Choose a Lambda function template. Select the Lambda trigger template to create your function. Writing the Lambda function code to send push notifications. Write the logic to send push notifications using your Lambda function's Expo push notification service. Const Axios equals require Axios. Exports.handler equals async event equals greater than. Const push token message equals event. Const response equals await Axios.post https://xb.host/api/v2/push/send. Push token. Sound, default. Body, message. Semicolon. return response.data. Semicolon. Configuring Lambda function triggers. Connecting the Lambda function to DynamoDB triggers. To automate push notifications, configure the Lambda function to trigger when a DynamoDB table is modified. Create a DynamoDB stream. Enable streams on your DynamoDB table. Connect stream to Lambda. In the AWS Management Console, link the DynamoDB stream to your Lambda function, ensuring the Lambda function runs on table modifications. The Lambda function should be configured to run whenever there are updates to the push token field or when a new item is added to the table. Testing and debugging. Using Cloud Watch Logs for troubleshooting. AWS Cloud Watch Logs Lambda functions, which can be invaluable for debugging. Check Cloud Watch Logs. Navigate to the CloudWatch console to view logs generated by your Lambda function. Analyze errors. Review log entries to identify and fix any issues. Creating test events based on logged events. Test your Lambda function by creating custom test events in the AWS Management Console, simulating DynamoDB updates. Security considerations and best practices. Limiting permissions for the Lambda function. To ensure security, limit the permissions granted to your Lambda function according to the principle of least privilege. Fine-tune IAM roles. Ensure the IAM role associated with your Lambda function has only the necessary permissions to access DynamoDB and send notifications. Review security groups. Regularly audit your security settings to avoid exposing sensitive data or granting excessive permissions. Conclusion. Integrating Expo with AWS services like DynamoDB and Lambda allows you to build robust real-time push notification systems that engage users. This setup focuses on security and best practices and ensures your application remains robust and scalable. This podcast should guide developers through the process, providing clear instructions and best practices to achieve a seamless integration. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.